Okay, so now I'm gonna pass the microphone over to Adam Leeper here from the Biorobotics Lab.
Okay. So yeah, I'm from the Biorobotics Lab. My name's Adam. My advisor is Ken Salisbury. And the Biorobotics Lab is a bit of an eclectic group. Lots of different interests listed here: medical simulation, medical robotics, traditional robotics, and haptics. And in such an environment, there are lots of different projects going on. And actually, the first generation of the personal robot, the PR1, came out of this lab. Our goals for the PR2 are in the areas of hardware, manipulation and teleoperation, and some human interaction. So I'll talk about the hardware first. We'll actually be working with an alpha version of the PR2, and this will make it easier to hack into certain areas of it. So one interest is developing a wrist attachment to have better force sensing. Another area, and this is my research area, is adding stereo sensing to the hand of the robot to enhance its capabilities. Another interest is implementing a hand design that we've proposed to DARPA for their ARM-H program. And of course, we're open to hardware collaboration if people have other ideas of things that they would want to add. So I'll talk a little bit about what I've been working on in the area of manipulation and sensing. And actually, it's sort of skipping to the last line there. It's use of the hand-mounted stereo for grasping. So here's an early version hand that I built that has some stereo cameras on it. And I'll show a video here of basically the idea is using the stereo on the hand to basically collect a point cloud, track an object, and grab it. So it's doing this completely autonomously. I just took a few clips of it, basically following the object and grabbing it. And this is in real time. So you can see my hand is on the joystick, basically a dead man switch. And then once I've grabbed the object, I say, OK, now I teleoperate it to move it away. I guess part of the goal would be, did I lose the, there we go, would be to implement a similar system on the PR2. In the range of teleoperation, so we've got now 2 great arms that could be used for mobile manipulation by a teleoperator. So an interest with one of our sponsors is to have teleoperation where there's more supervisory control, but you can make use of a lot of the local autonomies that the sensors can give you. So for example, obstacle avoidance, maintenance and sort of refinement of grasp positions and orientation, and waypoint navigation. And so an example of that is in this video, using that same arm. So I'm just sort of holding a button that says follow the object, and then I can command in like, hey, change your orientation about the object. So that's the sort of, the human is inputting some changes to his commands, but the robot is responsible for the sort of local tracking of the object. Now moving on, we've got some collaboration going on with the communications department at Stanford, and so we're interested in some experiments to have the robot interact with humans. So the first would be to detect faces and people and have the robot gesture at people to basically let them know that it knows that they're there. Because it seems like a lot of things in robotics that might make people more comfortable to have the knowledge that the robot sees them. I put a line there, have the robot stalk people lovingly. Again, this goes, some other people talked about it, but basically following people in a crowd and things involved with that. Handshaking. And then this leads into sort of other physical interactions. So taking and receiving, or taking and giving objects, and leading and being led, and basically anything dealing with touch. So, of course, the PR2 can sense a lot of these things, has good visual sensors and also the fingertip sensors. But we would like to expand some of those capabilities, in particular the force sensing. So I guess that's what we have.